This is the number grid. The term number grid is not a technical math term. As you can see, it's just a grid of numbers, but the numbers are organized in a very specific pattern. If we start with any number and move one space to the right, the value increases by 1. For example, if we start at the number 15 and move to the right one space, we get to the number 16. This idea allows us to do some basic arithmetic. For example, 11 plus 4 means that we start from 11 and move 4 spaces to the right. So starting from 11, we move 4 spaces to the right, 1, 2, 3, 4, and we end up at 15. This tells us that 11 plus 4 is equal to 15. What happens if we want to do 19 plus 3? We can't move 3 spaces to the right from 19, so what can we do? It's kind of like reading a book. When you get to the end of a line, you go down to the next line and start over from the left. This allows us to finish the calculation. Starting from 19, we move 3 spaces to the right, 1, 2, 3. So 19 plus 3 equals 22. If we start with any number and move 1 space to the left, the value decreases by 1. For example, if we start at the number 42 and move to the left by 1 space, we get to the number 41. The same idea applies when we get to the end of a line, except that we're going to do it backwards. If we try to calculate 32 minus 5, when we get to the end, we go up 1 row and start at the right. By counting it out, we would see that 32 minus 5 equals 27. The underlying intuition when we get to the end of a line is that we really want to think about this as being a continuous strip of numbers. The line breaks exist partially for convenience, but the choice of making each line 10 boxes wide is intentional. Let's look at a number grid that's 8 boxes wide. Notice that the numbers look a bit messier. They just don't line up as nicely. Why does this happen? This is an artifact of how we write numbers. Our place value system is built around making groups of 10. That's why it's called the base 10 system. If we have 10 ones, we get a 10. If we have 10 tens, we get 100. And 10 hundreds, we get 1,000, and so on. By making our lines 10 boxes wide, we get nice columns of values that are easy to work with. What happens if we start from 24 and move 10 spaces to the right? Let's count it out. Starting from 24, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That takes us to the number 34. Moving 10 spaces to the right is the same as moving 1 space down. This makes sense because each line is 10 boxes wide. We've gone the same distance to the right as 1 full line. What would happen if we started from a number and moved 10 spaces to the left? Your intuition should tell you that it's the same as moving up 1 space, and your intuition would be correct. Moving to the left 10 spaces is the opposite result of moving to the right 10 spaces. This gives us the arithmetic behind the movement in our 4 basic directions. Moving to the right 1 space means to add 1. Moving to the left 1 space means to subtract 1. Moving down 1 space means to add 10. And moving up 1 space means to subtract 10. There's an underlying idea here, which is that addition and subtraction are inverse operations. All it says is that if you add a number and subtract the same number, you get back to where you started. The reason we want to build out these patterns is to get students to play with the numbers a bit. What would happen if we started to remove some numbers from the grid? Could the students figure out what numbers go into the holes? Notice that even if you didn't quite fully understand numbers, you would have a good chance of filling in the right symbols for the space based on the patterns. Again, this is the benefit of using grids that are 10 boxes wide with our base 10 system. And this helps students to begin to associate the numerical symbols with the appropriate numerical values. This puzzle can become even more complex. In some problems, students will be given just a number and some empty boxes surrounding it, and their task will be to fill in the numbers. With your current level of experience, you should be able to figure out pretty quickly what numbers belong in the boxes. But we also want you to know how to help your children think through the boxes. Remember the pattern. 1 space to the right means to add 1. 1 space to the left means to subtract 1. 1 space down means to add 10. 1 space up means to subtract 10. So we will start from 65 and move 1 space up. This means to subtract 10, which puts us at 55. Then we move 1 space to the right. This means we need to add 1. This takes us from 55 to 56. For the next step, we need to move right 1 and down 1, or down 1 and right 1. It doesn't really matter. So starting from 56, if we move to the right 1, we get to 57. And then if we move down 1, we get to 67. There's so much more that can be done with this number grid. For example, we can have even larger numbers in the grid. Even though these are all 3-digit numbers, you can see that the basic pattern still remains. We can also start with a number grid and shade in multiples of a single number and look for patterns. For example, here's a grid with the multiples of 2 filled in. And here's a grid with the multiples of 3 filled in, and the multiples of 5, and the multiples of 8. Notice that each one has its own pattern. And if we look at them all at once, we can see other types of patterns. For example, the multiples of 2 and the multiples of 5 both make straight columns. Now, there's a good reason for this, but we will let you think about this one for yourself. We hope that this video helps you to understand more about the math behind the worksheets that your children are doing with number grids.